Hello, everybody. My name is Angeline Ferdinand, and I am a bioethics academic at the University of Sydney. I am coming to you today from Gadigal land, and I would like to start by acknowledging that I am on unceded Aboriginal land, and I pay my respects to elders past, present and emerging, and also any Aboriginal or Torres Strait Islander peoples who may be joining us this afternoon. Welcome to the second event of the Australian ELSI Genomics Network, which is an initiative supported by Australian Genomics. And I'm the initial leader of this network, and it's my pleasure to have you with us this afternoon. We have two excellent speakers who are going to give some presentations that are complementary regarding epigenetics. We have Angeline Ferdinand and Evie Kendal. And Evie is going to speak first, followed by Angeline, and then we'll combine questions. If you have a question, feel free to pop it in the chat in the meantime. So, I'll start actually by just introducing Evie. Evie is an academic. She's a lecturer at Swinburne University and has a long history of work on emerging topics. And Evie and Angeline have both recently spearheaded an initiative at the Brochet Foundation in Switzerland. And today's presentation on ethics and epigenetics bounces off that event that they held. Evie, I think we might actually allow you to commence sharing your slides and hand over to you for your presentation. Thank you.
Okay, so I'll just try to get full screen. Scroll a little. Excellent. Okay, so can everyone see my screen now?
It looks great to me. Thank you.
Fantastic. I'll just start my timer to keep me on track. So I would also like to acknowledge that I'm currently on the lands of the Wurundjeri people of the Kulin Nation and to pay my respects to their elders past and present. So the first issue that I want to talk about when I'm looking at emerging technologies, and I'm particularly interested today in epigenetic and genetic technologies, is our bread and butter bioethics issue of consent. But it is a little more complex in this case because we have potentially a bit of a conflict between individual and family or societal consent. So popular conceptions of patient autonomy often focus on the right to self-governance and promotion of informed consent for interventions, possibly at the expense of considering the impact of social influences on individual decision-making and vice versa. When it comes to emerging technologies, there's also the issue of establishing how informed consent can be gained from individuals when the effects of novel technologies are uncertain. While it is typically recognised that patients and research participants do not make decisions in a vacuum, less attention has been paid to establishing the reasonable limits of individual freedom when these decisions might have broad consequences for others in society. There are two areas where this proposed conflict is perhaps best exemplified: the field of genetics, where family and other group information is involved, rather than just personal data, and emerging technology ethics, where there might be compelling grounds in some cases to curb individual freedom to avoid societal harm. So on the individual level, we can see concerns regarding whether there are public misunderstandings about genetic technologies. For example, that risk scores might mean you inevitably get the disease they're looking for, or social and psychological harm of unregulated testing markets, so including that direct-to-consumer market that you may have heard of. We're also concerned with data privacy. So this is a concern for individuals, but also for societies and for families. So there are calls in genetic ethics to move away from the individualism of principalism and incorporate aspects of non-Western medical ethics that elevate the position of familial consent in treatment decisions. At our recent symposium in Geneva and the online version we ran last year, we were fortunate to hear from various First Nations researchers regarding potential alternatives to individual consent for genetic and epigenetic research, including the tribal consent models, and that's the preferred term in the region, used in parts of the United States of America. Many of these talks are already online to view if you wish. So perhaps we need to be developing these family or societal consent models with a concern for data ownership and governance. We are also concerned, of course, with equity, and on the individual level, that's going to be issues of justice, so fair distribution of burdens and benefits, but also things like precision medicine is based on a lot of data, and it can develop more effective treatments for things like cancer, so chemotherapy regimes, but it's often unfunded at some of these levels. So Medicare may not be able to fund this precision medicine for everyone. So of course, that's an issue of equity. At the societal level, of course, genetic data and knowledge impacts health equity, and we need to ask whether these are the best uses of our limited resources. So how can cost-benefit analyses be conducted if we don't know the benefits? They haven't been demonstrated yet, and the harms are also unknown. And these expensive tests, perhaps we actually have better ways to use our money. So these are questions we might want to ask. Again, if we look more broadly at society, are there alterations to the human genome that we want to prevent? So transhumanism, the splitting of humanity into H and H+, this might be an issue that we want to consider. So that brings me to my two main ethical case studies for today, biohacking and bioengineering, and later bioprospecting. So for biohacking and bioengineering, at the individual level, we're looking at things like extreme body modification, prosthetics, insidables. So these are things that people actually inject inside their body. A famous case recently in Australia was Meow Ludo Disco Gamma Meow Meow. That's a person's name, it's a great name, who was actually taken to court for misuse of one of the public transport system cards because he had the RFID chip actually inserted into his hand to use at the stalls. There was no crime involved because there had not actually been any need to develop a law against this. No one had tried it before. We're particularly interested, of course, in things like garage use of CRISPR-Cas9 to achieve transhumanist goals. So if we move into that sort of transhumanist idea, some argue that transhumanism is inevitable because of this DIY biohacking that's now possible. So people can have insidables implanted in the same way they used to have Botox parties. So they can all come together. What we're seeing in these kind of like implant parties and Botox parties is a new form of biocitizenship. So united by common interests in body modification and often anti-aging, we see people actually gathering together to achieve these goals. They're no longer disease communities trying to use their collective force to pressure governments and other organizations to listen to their concerns regarding Plows and Boddington's quote here, access, price, quality, and availability of treatment and cures. In other words, over the increasing access to the fruits of biotechnology. So now we have collective mobilization over not just health issues, but for biohackers, human enhancement issues. And that includes those who want to use CRISPR-Cas9 to achieve that goal. So we're actually seeing people who are moving away from anti-aging in that sort of geriatric medicine into human enhancement using genetic and epigenetic technologies. And this is a whole new biosocial order. So connections to direct-to-consumer ancestry and so-called epigenetic age tests are quite clear there. Here we need to ask ourselves, is there a real third-party harm here in allowing these modifications in biohacker communities, given the fact that they actually have implications for everyone else as well? So that's the individual level. Should we curb that individual right to consent to these extreme modifications? At the institutional level, societal level, we might have concerns about employers wanting to use things like genetic engineering and enhancement to optimize their workforce. So Gao notes that regulatory documents regarding gene editing typically focus on 4 scientific concerns, those being off-target effects, on-target effects, epigenetic effects, and chimerism, and various social justice concerns predominantly focused on inequitable access to gene editing technologies on socioeconomic grounds. Off-target issues, if you're unaware, refer to when modifications occur at the wrong place in the genome. By contrast, on-target effects refer to when the correct target is isolated but with unintended results, such as large deletions, translocations, or activation of cancer-causing oncogenes, which is unfortunately something that we did see when we used gene therapy for SCID, so X-linked severe combined immunodeficiency. Some of these child patients later developed leukemia due to abnormal activation of the LMO2 protein coding gene. According to Seed House, if we look at institutional use of this, NASA is currently considering both genetic and epigenetic modification for astronauts. So the latter is focused on changing the way the body reads genes without affecting the underlying DNA. Epigenetic changes can dictate gene activation, deactivation, protein transcription, and reactions to environment and behavior, thereby altering phenotypic expression without changing the DNA sequence. However, under epigenetic effects, Gao notes the risk, for example, that insertion of a radiation resistance gene is epigenetically turned off, rendering that genetic modification useless. Finally, chimerism refers to when gene modification does not occur in all target cells, leading to a mixture of modified and unmodified genes in the recipient. For all those issues, the possible effects range from having no impact to diminishing the effectiveness of an intervention or a natural process, to genes or the proteins they encode developing a toxic or even lethal function. So this can knock out essential processes for an organism. We can very reasonably ask whether these are risks we want to be avoiding at the species level, but also whether we think institutions should be banned from promoting a sort of genetics arms race among citizens or employees. Another ethical concern relates to where the target genes for engineering have been located among the global population. And that brings me to my second case study here, which is the issue of bioprospecting. Bioprospecting refers to investigating living things to find commercially valuable biochemical properties and can include exploiting various genetic traits for profit. Using the NASA example again, they would be looking for mutations or changes to the epigenome that would confer survival advantage for people operating in extreme environments. So that means environments of reduced oxygen and pressure, extreme temperature, reduced access to fresh food and water, for example. According to Sharp and Braddock, there are numerous examples of human extremophiles showing adaptation to reduced oxygen levels, including the Bajau people of Indonesia, who have shown evolutionary adaptation to hypoxia by developing larger than average spleens where oxygenated red blood cells can be stored. This adaptation is owed to alterations to a gene involved with thyroid hormone level regulation and is believed to have occurred due to the cultural practice of sustained breath hold diving. These authors also note genetic factors found among Tibetans, Andeans, and Ethiopians living at high altitudes that confer advantages for gaseous exchange in the respiratory system, including mutations in 5 different genes. I do have lists of all the relevant genes, but because they're just sequences of letters and numbers, it's a bit boring. But if anyone wants the references, I'm very happy to send them through. These mutations all have relevance to adapting to low pressure environments as well, alongside 5 other candidates for high and low pressure adaptation. Some polymorphisms of NOS3, for example, have been shown to protect against neuronal injury in hypoxic ischemic encephalopathy among the Chinese Han population, where the incidence of this condition is higher in neonates than the global average. Key et al. Also found a variant of the, I will read this one out, TRPM8 gene. I won't read the variant because it's just R and a whole lot of numbers, to be present in very different frequencies among populations according to the local temperature conditions, reporting a 5% frequency in Nigeria, but 88% in Finland. These authors state these genes encode for a cation channel that is to date the only known temperature receptor to mediate endogenous response to moderate cold. Again, if we want to have people living on the moon, this would be a very useful trait to exploit. When it comes to adapting to food and water shortages, Argentinian Andes populations have shown increased tolerance to arsenic due to selective pressures for a specific allele of a gene involved in arsenic metabolism, so they can eat food that would otherwise be toxic. Adaptations to high-fat diets needed to provide enough energy to survive in low temperatures have been seen at 5 different gene locations in Siberian people and Inuit populations in Greenland. Meanwhile, studies of various Arctic populations have found extreme cold and the lack of available dietary plants for much of the year has led to genetic adaptations involving the CPT1A gene, which is involved in fatty acid oxidation. According to Hale, the relevant variant underwent one of the strongest known selective sweeps in human history and is specific to Inuit and Yupik populations, where it may compensate for low carbohydrate and high protein consumption. Adaptations involving genes associated with elevated serum urate levels, which have a role in preventing dehydration, have also been found in Australian Indigenous communities. So this all demonstrates that a lot of the conserved genes considered useful for genetic enhancement are actually found in remote and Indigenous populations. In many cases, these communities are unlikely to directly benefit from research that is conducted on them. However, they are the communities that bear the risk of harm. So risk of discrimination, loss of data privacy, and outside governance of their data and biological samples. So of course, we want to make sure we have that equitable distribution of burdens and benefits in research and in healthcare. And what we're seeing here, of course, is quite the opposite. There are some attempts to redress this disadvantage and discrimination. So protecting data governance from within these communities, of course, things like sample repatriation. So if samples have been taken and banked elsewhere, they're being returned to Indigenous communities, for example. But also there are arguments coming through the literature regarding bioreparations that try to take into account the effects of transgenerational trauma on the epigenome and health. So these are just some of what's sort of moving forward in the field. So my final point here is about what do we actually do with these emerging genetic and epigenetic technologies as ethicists or policymakers or educators. And we have here our classical trolley experiment, but of course there's a crystal ball on one side, so we know exactly what's going to happen. So we have this anticipation of what's going to happen. This is technology that hasn't been proven yet, so how do we handle that? So first we have the precautionary principle. We'll all be familiar with that. It formalizes a precautionary approach to emerging technologies, particularly those involving potential harm to human health and the environment. This principle originated in German domestic law in the 1970s before being adopted as the dominant approach to regulating new biotechnologies throughout Europe from the 1990s onward. One of the main regulatory areas where the principle is discussed is in European legislation surrounding genetically modified food. Many argue this precedent will likely impact the treatment of more novel gene editing techniques, such as CRISPR-Cas9. At its core, the principle translates any potential for harm in the face of scientific uncertainty into a positive duty for stakeholders to act to prevent or mitigate this harm. Thus, use of the principle is often criticised for unreasonably blocking technological developments, including those that could yield significant health benefits for the population. The next potential way to deal with it is using a design ethics approach, which takes into account the social and ethical dimensions of the context in which a product is designed and will be used. One of the more common methods, of course, being value-sensitive design, which tries to identify relevant human values during technology research and development phases to ensure they are promoted and respected by the design. These include respect for privacy, environmental sustainability, accountability, and many other values that are at stake in the interaction between people, technology, and the environment. When it comes to new technologies with unknown risks, this model would support adopting preventive measures to mitigate harm, but could also allow for controlled learning experiments, where step-by-step potential risks can be explored as the technology develops. So that would include, of course, genetic and epigenetic technologies and treatments. We also have ethical technology assessment. So Middlestart et al. Note that traditional technology assessment arose in response to undesirable or unintentional side effects of emerging technologies, with a primary focus on considering the impact of technology on the environment, industry, and society. While technology assessment has been highly influential, particularly for establishing environmental impact assessments and other forms of risk analysis, Palm and Hansen claim ethical and social dimensions of emerging technologies have often been neglected. They propose the ethical technology assessment, the ETA approach that adjusts development in line with ethical concerns and guides decision-making. Their ethical checklist contains 9 items that, if implicated in an emerging technology, indicate an ETA should be conducted. Examples include if the proposed technology might be expected to affect concepts of privacy or gender minorities and justice. So most emerging genetic technologies would meet several of their criteria. Finally, it's well recognised that governing emerging technologies is difficult due to uncertainty regarding their impact on human health, the environment, and society. Hester et al. Suggests one method of addressing this is to adopt regulatory systems that rely on anticipatory ethics and governance, future-oriented responsibility, upstream public engagement, and theories of justice. These would be forward-looking and flexible, allowing cautious development of technology instead of enforcing bans or merely being used to impute responsibility for harm after the fact, as is often seen in current legal systems. Noting that existing ethico-legal approaches tend to be reactive and static, these authors promote a future care-oriented responsible innovation that protects public trust in science and technology. Nestor and Wilson's anticipatory practical ethics methodology allows for ethical consideration of not just future technologies, but also future stakeholders, for example, children produced using CRISPR or similar technologies. These authors distinguish between anticipatory ethics, where ethical theories are applied to novel situations impacting various stakeholders with the goal of providing policy recommendations, and anticipatory governance, which develops policies in line with predictions regarding human behaviour. Anticipatory ethical systems are also subject to criticism, though, including that because they speculate on future technologies, they might waste time conducting analyses on things that never come to pass. Further, in their attempt to preempt future applications of new technologies, Schick claims speculative ethical models may miss crucial stages in the process, as demonstrated by the example of genetic engineering. Now, this is quite a long block quote, but I'm almost at the end, so bear with me. So he states, the mainstream bioethics discourse on human genetic engineering, i.e. primarily in the US and the UK, was not indexed to the current state of science or slightly ahead of it, but instead took up questions entangled with more distant, anticipated future developments. Keeping the discourse well ahead of the curve of emerging biomedical technologies probably generated interesting discussion, but it may also have contributed to the weakness of the consensus-based norms that were thought to be keeping human germline genetic engineering in check. In effect, the forward-looking discourse subjected them to what might be called anticipatory obsolescence by asking whether to maintain a distinction between somatic and germline therapies long before there was a technique up to the task of altering the genome of a human embryo with sufficient efficacy to begin considering preclinical human embryonic interventions. Once human embryonic gene editing became possible, Schick claims the newly urgent question of whether germline interventions were ethically permissible was no longer where the discussion was centered, as speculations regarding human enhancement had started to dominate bioethical debate on the subject. They continue, in retrospect, it seems almost inevitable that once germline engineering was accomplished, the old question of whether it should be undertaken at all would suddenly become obsolete. Thus, there is a risk that by focusing too much on future applications, ethicists will miss the opportunity to intervene in foundational science stages of technological revolution. So these are just some of the possible ethical frameworks that we could apply to future biohacking or bioprospecting technologies, but whichever we choose will have different approaches to consent, data management, and equitable distribution of the burdens and benefits of research. Thank you.
Thank you so much, Evie. I'll just invite you to stop sharing your screen for now. And we'll hold questions until the end of Angeline's presentation as well. So it's my pleasure to welcome and introduce Angeline Ferdinand, who's a researcher at the University of Melbourne. Angeline has undertaken lots and lots of work on health equity in all its many and diverse forms over a large period of time, and is currently undertaking a project looking in particular at genomics and also with respect to Aboriginal and Torres Strait Islander Australians. Angeline, I'll invite you to share your screen and start your presentation. Thank you so much.
Thank you. Thanks, Ainsley. And hopefully everybody can see that.
Yes, it looks great. Thank you.
Okay, great. Thank you so much. Thank you, Ainsley, for the introduction as well as the opportunity to talk to you all today. So I'll be speaking primarily about the trajectories between undertaking genetic and genomic research and equitable research outcomes or access to benefit from this type of research. And I would also like to acknowledge and pay my respects to the owners of the unceded land on which I am today, on which I live and work, which is the Wurundjeri people of the Kulin Nation, and pay my respects to their elders past, present, and emerging. I would also extend that respect to the traditional owners of the lands on which all of you are, as well as to Aboriginal and Torres Strait Islander and First Nations people and colleagues on the call with us. So I think probably we're all here on this call today because we all are excited about the increasing genomics capacity and capability that we're currently experiencing, and acknowledging the opportunities for positive impacts on clinical medicine and health outcomes. However, we also have to acknowledge that there's the potential, as with any new technology and with any health technology, there is the potential to further entrench and exacerbate health inequities. I particularly like this this chart here because it does show the cyclical nature of particularly genetic research. As many of us on the call would know, diverse populations are underrepresented in genomic studies that form the foundation for linking genes and disease. And they're also underrepresented in access to clinical genetic care. And as the cyclical nature of this research represents, because there are particular cohorts that are underrepresented at every stage of the cycle, this disadvantage becomes further and further entrenched, or has the possibility to in any case. So I'd like to take a step back. Sorry, I'm just trying to. So I'd like to take a step back and think a bit about what we mean by ethical benefit sharing in health research. And I found this paper to be really useful for framing some of my thoughts. I'd like to say from the beginning that this particular, similar to Evie's presentation, I don't necessarily come to any conclusions in this talk. It's really some of my own thoughts informed by my own research and some of the literature around ethical, ethical distribution of benefit in genetic research, genetic and genomic research. So I'm really looking forward to the breakout sessions and the Q&A sessions where we might be able to talk about some of these issues further. But I won't be coming to any firm conclusions or anything like that. So I guess taking a step back and thinking about what we mean by ethical distribution of benefit. And this particular paper I found to be quite interesting in doing so. So it's a two-dimensional framework thinking about the promotion of health benefit sharing. And this is across all health research, so not specific to genetics or genomics. And this particular framework thinks about two dimensions, the first being stakeholders at the macro, micro, meso, and micro levels. So stakeholders at the national and regional level, global level, stakeholders at the provincial level, and then micro level stakeholders, so individuals, families, and communities. And it also thinks about the types of benefits that can be shared across the different stakeholders, from financial to health and well-being, down to career development and attribution and recognition. And the purpose of this, I found this particular framework to be quite useful in terms of mapping the types of benefits that might come out of health research, and thinking about who might be benefiting from what type of benefit. And we can think about the ways that the different levels of stakeholders might accrue different types of benefits. So for example, we would think that career development, attribution and recognition and so on might be more likely to accrue at the institutional level or at the academic level. Whereas hopefully, if the system is working correctly, we would see benefits in the health and well-being category accumulating at the micro level, services capacity possibly at the meso level. So I find it useful for mapping that flow of benefit, but at the same time, I find it difficult to weigh different elements across stakeholders and stakeholder groups. So it's difficult to know whether the attribution recognition or the financial gain or benefit that institutions and academics might realize is in proportion or in balance with the health and well-being benefits that we would hope community members and individuals are able to access. I also find this a little bit lacking in that the micro level and other levels are also able to, I suppose, hide differential costs and benefits. So as Evie said, within that micro level in particular, there may be some populations or some communities that bear higher risk of harm or have experienced higher risks of harm with limited access to benefits. So looking at it only at the category level or at the stakeholder level doesn't allow us to undertake that type of analysis. So on the other hand, we have this paper defining and achieving health equity in genomic medicine. And I really enjoyed this in particular. The authors, Juma and colleagues, define health equity in genomic medicine as the global applicability of genomic knowledge, fair and even access to genomic services, such as testing and counseling, and unbiased implementation of genomic medicine. And I particularly like this framework because as I was going through and reflecting and reading a bit more about health equity in genomic medicine, I found that a lot of the focus on equity in genomics is really at the level of genomic research, which of course is necessary and logical, but there was less on access to genomic medicine and the benefits of clinical care. The authors here go on to say, successful implementation of genomic medicine will mean that all populations have equal, effective, and affordable access to genomic medicine, and that diagnosis, prevention, and treatment strategies can target the basis of disease without bias for or against any group. So here again, going back to that idea of the trajectory between the genetic research and the way that genetic research is conducted and the access to treatment strategies and treatment and access to clinical genomic medicine. These authors outline 3 different factors in what they see as health equity in genomic medicine. First, addressing gaps in the evidence base. So really looking at the way that genetic research is being conducted. So here we have the availability of genomic information from particularly non-European populations, the need for ELSI research, thinking about the ways that questions like genomic literacy, informed consent, and so on affect minority and underrepresented groups, which Evie touched on. Implementation of genomic medicine and the ways that genetic care can be made more culturally competent, which I'll speak about in a little bit. And ensuring that, that resources and time are allocated to properly engage with communities in the course of research. And we'll touch on this a little bit more in a bit as well. Secondly, reducing disparities in access to genomic services. So reimbursement policies for genomic testing, looking at cost effectiveness and clinical utility of the genomic tests, and in particular, incorporating diversity in implementing genomic medicine. And then finally, building stronger infrastructure outside traditional academic medical centers. So disseminating technology in diverse clinical settings, healthcare settings, and also strengthening a diverse infrastructure and workforce development. So we see this in a number of different initiatives, such as H3 Africa and the summer internship for Indigenous peoples in genomics. So I'd like to touch on a few aspects of equity or inequity in accessing genetic healthcare. And this is from some work that I've been involved in, the Better the Better Indigenous Genetic Health Service project, which was undertaken in 2016 to 2019 in the NT, Queensland, and WA. And for this project, we undertook qualitative data collection, so interviews with Aboriginal and Torres Strait Islander patients, parents, and carers, again in those 3 jurisdictions, as well as interviews with clinical genetic services, practitioners, and other staff. And then we undertook an administrative audit looking at quantitative administrative data in each of the jurisdictions. And essentially what we found is that while the patterns differed across the 3 jurisdictions, we found evidence of inequity basically across all stages of the patient journey. And this ties in with other evidence of significant unmet need for clinical genetics and genetic counseling among Aboriginal and Torres Strait Islander Australians, and considerable gaps in terms of the comprehensiveness of those services and continuity of care when they are able to be accessed. So in our research, we found that there was a clear difference in how in the referral rates between Aboriginal and Torres Strait Islander and non-Indigenous Australians, where Indigenous people were referred to clinical services. There was a lower incidence of scheduling appointments. For those individuals that did have appointments scheduled, there was then a lower rate of attendance for the genetic services. We also found that there were barriers at each level, at each stage of the patient journey. So at the pre-appointment stage, where people didn't necessarily have a good understanding of why they had been referred to genetic services, especially if they had a child, for example, that was being referred, but had many other health issues that they had to attend to. Genetics tended to fall to the bottom of the list. There was also misunderstandings around the cost, for example, of the test, what was going to be expected of them, and what they could expect at the genetic service appointment. There were barriers during the appointment relating to the physical space sometimes, as well as issues in communication, genetic literacy. And then after the appointment, in terms of not knowing where to go to for further information, not knowing what the next steps were and who to contact. When we talk about inequities in genetics, in genetic research or genetic services, we do often think about inequities in terms of cultural and ethnic diversity, but there are other axes as well. So this is coming from a systematic review of geographical inequities for accessing clinical genomic services, genetic services. And while it is coming from a systematic review, it also reflects the Australian experience, where we know that there are inequities for people in rural, regional and remote areas. And I won't go through everything in this slide, but that goes from the aspects of inequities range from the current service model design through to logistical issues, the workforce capacity and capability, and culture and consumer beliefs. So I guess the last point that I wanted to make was thinking about whose responsibility is it in terms of ensuring equitable benefit, distribution of benefit. And I suppose as a researcher, there is increasing pressure to indicate that your research you're able to translate your research findings, that the research findings are being taken up by others who are able to use it, and so on. But there's also increasing acknowledgement that researchers by ourselves are not able to ensure that our research is being used appropriately. So going back to the JUMA framework, researchers obviously have a role to play. And here we're only looking at a few points in terms of who's responsible, who has responsibility in this area. But thinking about ourselves as researchers having responsibility to increase community engagement, to ensure that we have relationships with the communities that we're working with, and that the concerns of local communities are being addressed. And this also goes back to some of the points that Evie made around informed consent and what that actually looks like. We also have the responsibility to think carefully about what types of questions we're asking and trying to answer. So building on the evidence base and thinking about what that evidence base should be looking like. On the other hand, we have the responsibilities of funders and institutions. Of course, as researchers, we're not able to do very much unless we have funding arrangements that allow us to work appropriately with communities. So ensuring that the timelines, for example, are appropriate for community engagement, that we have sufficient resources, and often that's not the case, as most researchers on the call can probably say. Thinking about the type of research that's funded, and thinking about funding and supporting the capacity in minority populations and underrepresented populations, so that communities are able to develop research that is representative and responds to their own needs and priorities. And then policymakers, again, facilitating access to genomic services in a variety of different ways. So again, I'm really keen to explore these topics further in the Q&A and then in the breakout rooms, and really keen to hear what other people think about, again, in terms of responsibility and what equitable benefit might look like at all stages of the pipeline, from genetic research all the way through to access to genetic services. And here I'm just going to end with a plug for our special collection. So Evie and I are editors on this collection for the International Journal for Equity in Health on equity and precision medicine. So we're inviting comments, short comment pieces, as well as longer research papers on that whole list of topics of interest. But if there's anything that you've been writing or thinking about writing and you think that it might be relevant, I would highly encourage you to reach out to either Evie or myself, and we'll be really keen to have a chat. For this collection, full paper submissions are due in October, but there is some flexibility with that deadline, so please reach out. And thank you so much for the opportunity.
Thank you so much, Angeline, for that really detailed and extremely clear presentation. One thing I just quickly did was Googled the special issue, and I'll pop the link to that call for papers in the chat now. Thank you.
Thanks, Angeline.
And thanks for stopping sharing your slides as well. So we have about, we're running exactly to time actually, which is perfect. We have about 25 minutes for questions before we head off into some breakout rooms, which is both to talk about the substantive issues that have come up today, but also just to meet each other and say hi. And so I'll start by just seeing, first of all, whether anyone has any questions. And just to make it easy for me, could you please use the raise hand function? Or if it's possible to do, could you please pop a question in the chat? And I might start by asking a question. I hope this isn't too high level. I think it's a really interesting idea to think about this idea of how these issues play out in different applications of genomics. So Evie, your talk was very wide ranging around lots of different applications, but we obviously testing and screening and thinking about more molecular level kind of straight up measurement of DNA is more established than epigenetic testing and knowledge and analysis. And just when it comes to thinking about questions like equity, I guess either of you are welcome to comment on this, or both of you perhaps. Do you think when it comes to emerging epigenetic tools and testing, what take homes from existing equity debates? What do you think might need to be adjusted or changed, or what do you think we can take from the existing debates? Sorry, that was a very convoluted way of asking the question.
Hey, that's okay. I'll briefly go first, and then Angeline, I'm sure, will have a more detailed sort of response there, sort of more practically focused. But as you know, a lot of what I do is very speculative, so it's looking at what is like the extreme use of this technology. And what we often find, of course, is the more speculative, the more technologically driven, is also the more expensive, and it tends to end up being something that wealthy people get access to first. And if you can pay for these precision interventions, then you can get them. But if you can't pay for them, then you have to settle for the existing thing here. So we have that issue where something very expensive is going to be only allowed for certain people. It might have a lot of benefit, it might not. But what we also find is by allowing the technology to develop even under those conditions, eventually there are some flow-on effects that other demographics can benefit from as well. So in terms of like the classic example was IVF, it was initially only available for more wealthy people, but now it has benefited a lot of people. And you could make the argument that some of those wealthier individuals at the start were the guinea pigs that took the risk. And now there's a more generalized benefit there. So with the sort of unfunded chemotherapy regimes, I hope that with further testing and refinement, they will become less expensive as IVF did, and therefore become sort of easier to support in something like the Medicare system. So it is a problem because, of course, we've also got that issue of these epigenetic studies in particular. They're often finding vulnerabilities. So they're looking at disadvantaged communities and what are their vulnerabilities. But in many cases, a public health approach has already identified the disadvantage, the social disadvantage, and there are much cheaper interventions that could have wide-ranging sort of positive impact on these disadvantaged communities. I think it is always a balancing act between sort of driving technology forward and eventually having more benefits for everyone, and of course being on the ground level and actually engaging those cheaper public health interventions that epigenetics gives us data to support, but we already know that there are problems and we already know things that we should be doing about it. I'll hand to Angeline.
Thank you.
Yeah, thanks, Evie. And you've really touched on pretty much what I was going to say. So as Evie mentioned, we often see, and again, I don't think that this is limited to genetic technologies, but health technologies, generally speaking, especially when they're first introduced, the benefits do tend to accumulate to people who already have access. And yes, while we would like to see eventually that benefit trickling down, as it were, the fact that it does initially accumulate at that level means that the gap in terms of that benefit continues to accumulate and continues to be exacerbated. So even though, yes, there may be benefit that arrives at more disadvantaged or people that have less access, there is that, again, entrenching of inequities and inequalities. I guess the other thing is that when it comes to development of technology or technological advances, the types of questions that are asked and the types of responses, again, tend to respond to the needs and the priorities and the wants of the majority. So it also goes back to what types of questions are we asking in the first place. Of course, in the case of genetics and genomic research, of course, we, as I mentioned, as many people here would know, There's the question of who's included in genetic research in the first place. So again, the underrepresentation of minority populations in the reference data. And then I guess also in terms of what kinds of questions we're asking, also goes back to what are we going to do about this information? So even if we have, as Evie alluded to, if we have particular, I guess, if we find out that there's a particular vulnerability in a population, whether that's something that is necessarily most efficiently treated or effectively treated through technological or diagnostic tools, or whether that's something that would more appropriately be addressed through public health interventions. So what is the purpose of the technologies that we're developing in the first place?
Yeah, thank you. Just on the diversity aspect, I think we can highlight here initiatives such as the Centre for Population Genomics, which is a joint initiative of the Garvan and Murdoch Children's Research Institute, which has as an express purpose to develop and enhance some of those representation issues in current data sets that are prevalent in Australia. And the other point that I think comes out from both of your comments is around choosing the best ways to use genomic information and using it when it can make an excellent difference at a public health level. And I think that's a theme that is prevalent in the literature and has been discussed as well. So thank you. Angeline, you look like you want to build on it. Yeah.
So I guess the other thing that I was going to say is who has the power and who has the responsibility to choose or have influence over how the technology is being used as well. So who makes those decisions around regulation, for example, around how the new technology is going to be funded, how access is going to be supported, and so on.
Yeah. And I think that's the importance of bringing in co-design and genuine consumer and patient engagement. There are a couple of questions in the chat, which I'll come to in just a moment, but Falak from Rare Voices, you've raised your hand. Hello, how are you? Thank you for attending.
Thanks. Thank you both for awesome presentations. I have to say I was pretty scared by yours, Evie. A bit of a terrifying topic. But, I guess I just wanted to, I think it's sort of related to what you're talking about in terms of, that having that privileged access to genetic testing or just because you have money. I'm looking at it obviously from a rare disease perspective where a lot of the time people will put their hand up for a clinical trial or take risks that others might not because they have no other option for treatment. So my question is, on the flip side of, if you have money and you just want to go for it and get that treatment, is there any sort of ethical framework that you can overlay on these people who have this really high risk appetite for participating in, genomic medicine or a precision medicine treatment that isn't fully tested?
Yeah, I guess I sort of touched on it as this is a question. Do we want to curb that freedom at the individual level for the societal third-party harm issue? And I think there are definitely compelling cases to be made there. I wouldn't want to say definitively one way or the other. And I guess the issue of that sort of medical tourism or that extreme risk appetite that you're describing, where people, if they have the money, they can go and they can do what they want, essentially. The issue there, of course, is if we don't allow anyone to do that, the technology won't progress in some cases. So if we decided, back in the 70s that because we couldn't give IVF to everyone, we weren't going to let anyone have it, then of course we wouldn't have it as a tool now, for better or worse. We don't all necessarily agree with the use of that technology. But essentially, I think there are cases where we might say, that extreme modification is potentially a harm to others. So it's that species level harm. I think it would be difficult to reach that threshold, but I do think it exists. And if we start saying that people who have resources can't use them for medical care, we would also be having to say, well, they can't use it for this and this and this because it's always inequitable. Healthcare is very special though. So these kind of arguments, you'll find them in healthcare. We are concerned about the genetic haves and the have-nots. But in one of my articles, we say we don't usually care about the Lamborghini haves and have-nots. It's a reasonable commodity by most views that, you know, luxury cars are something that some people can afford and others can't. We don't usually think about that beyond the fact that obviously wealth accumulation is unjust. We don't think about it beyond that as isn't it terrible that we don't all have a Lamborghini? But it is genuinely terrible that we don't all have a good standard of healthcare globally. And I think health is that special good that we are not willing to sort of abandon to unfettered market forces in the way we do things that are genuinely commodities. So I guess I wouldn't want to ban people using that. I wouldn't want to be unnecessarily restrictive on people's individual liberty there. But I believe that there is a threshold at which you can say that that degree of risk is harmful to the species. So we shouldn't allow anyone to engage in that. And when it comes to things like, you know, the medical tourism and the paying for your own treatments, your own precision medicine, for example, I think we also have to be very careful there. People sometimes argue that we don't want anyone to be excluded from, you know, genetic lottery, because if wealthy people never had children with particular genetic abnormalities, then a lot of philanthropic work would go away. I think that's a very dangerous way to think about the purpose of a child. But I mean, it does also have some financial truth. A lot of philanthropic money does come from people whose own children or own family have been affected by, say, a rare genetic disorder. And I think, again, it's one of those balancing acts. We don't want to be using an individual's family or any sort of health misfortune for other people's benefit necessarily. But if we did have a certain subset of the population that were always excluded from those risks, then we would find that I think society would suffer in terms of that solidarity.
Fallon, does that answer your question, or did you want to follow up?
Yeah, I guess my question was more related to, you know, whether there's some kind of an ethical framework or some kind of, because I'm not a bioethicist, but just trying to manage that high risk appetite in some people who don't have access to, you know, any treatment at all. And then a clinical trial comes through and it's, you know, very new and they're ready to put their hand up because they're desperate. I guess I really worry about them because, you know, coming from Rare Voices Australia and the fact that most rare diseases don't have a treatment and everybody's sitting around waiting for the best clinical trial to come available. Yeah, I've been for a while just very curious about how do we mitigate the risk for them when they've got such a high, well, this is a bit speculative, but I assume that they have a high risk appetite. And I know from experience that working with a lot of the rare disease community, that they really have this drive to be a part of research and they want to be there and they want to contribute and they want to see the next generation not have to suffer the way they did. So I guess just finding ways to mitigate that risk. And if there's anything out there that can support that,
Yeah, sorry, I thought you meant risk to the population rather than risk to the individual.
Sorry, Evie.
No, that's totally
that's
fine.
okay.
Thank you for clarifying. So, I mean, we do have that potential risk. If some people take extreme risks, it can be harmful to others. But if the primary question is like, do we allow them to take the risk themselves, particularly if they have no other option? I think it's very difficult to say to someone who, for example, is dying, we won't let you take the risk of dying. It's like you're dying anyway. And that can be meaningful for you or it can be not. And I think, you know, being involved in a clinical trial, even if it has no like medical benefit to that individual, it might have other benefits, social benefits. They might feel like contributing data, as you say, that the next generation don't suffer the same diseases or the same impacts. So I think it's very difficult to tell someone in that situation that they've somehow lost the right to give informed consent to be involved in a clinical trial. My concerns are usually focused more on things that are happening outside of that governance structure. So the garage use of this technology and how that can be quite harmful. But of course, we are very concerned about those individuals being infantilized in terms of their vulnerability. So because they're dying or they're sick, they have a rare condition, all of a sudden we're saying they can't direct their own fate, but also the extreme risk of exploitation given that vulnerability. So taking advantage of that person, we definitely want to be in a situation where we say, well, that person's dying anyway, so we can do whatever we want for the greater good of others. So I think, again, it's the same kind of response. It's always going to be a balancing act. And there are, of course, regulations. They are quite strict when it comes to, you know, who can actually be involved in some of these early clinical trials, of course, and they don't tend to they don't allow high risk regardless of those circumstances if they think there's considerable risk of harm.
Angeline, you looked like you wanted to add to that as well.
Thanks, Ainsley, and thanks, Evie. I'll just add, I guess the way, or one of the ways that I would think about the points that you raise is the balance between who is at risk or who is taking on the risk and who has the potential to benefit, and whether those are the same people or the same communities or not. And we know that in some cases, the populations that are at risk, that are giving their information or providing samples or anything like that, those are not necessarily the people that will benefit. And in that case, I would say that there's possibly, I would look quite closely at whether that's an ethical and equitable distribution of benefit. I think that in the case where the population or the individual is taking on quite a high level of risk or quite a high level of cost in participating in a trial or participating in research, although they might be bearing that risk and they might be bearing that potential cost, if the potential benefits also accrue to that individual or accrue to that community, however you define that community, and that can be very subjective and very flexible. I think that there's less of an ethical issue there, and I would see that as being a more equitable distribution. That being said, there's also the balance between how high the burden of risk or how high the burden of harm is versus the potential benefit. And whether that balances out, as you alluded to, often comes down to what is the potential benefit. If you're thinking about a rare and potentially serious disease versus something that might be more mild, and what does that mean for the amount of risk that an individual or community can and should take on? I don't know if that provides more information.
That's helpful. Thank you very much.
I also think, just to add a chair note here, is that this is a long-standing issue in research ethics, in the sense that it's not unique to this particular space, and I think it's a very delicate balancing of what we would in the bioethics world would call reasonable paternalism and individual interests in taking on risks that are appropriate to them and their values. And there's a very long-standing kind of academic debate in this area. We had a couple of questions in the chat as well. One was quite general and one was very specific. Jeff Craig asked quite a broad question around your thoughts on the extent to which, oh, Jeff, would you like to ask your question in person
Yes.
rather than me reading it out for you?
Yeah.
Hi.
Yeah, thanks. You raised some really interesting issues, Evie and Angeline. Thanks for doing that. The more I think about it, the more there's a lot in common between genetic and epigenetic tests, but there's also some differences in the ethical, legal, and social implications. Can you say a little bit about what you think could be different about epigenetic tests compared to genetic tests?
Sure, I'll start. So I guess one of the concerns that I have with epigenetic testing, and we spoke about it a bit at the symposium, Jeff, is how people respond to, I guess, the idea of epigenetics. And I guess you see it in the general literature and I guess the general media, where people think of epigenetics as something that, and genetics generally as something that's determined, and that's there's nothing that you can do about it, essentially. So Ainsley, I think you mentioned the idea that if you have a particular risk factor or a particular risk score, that there's the perception that there's not much that you can do about it, and there's possibly a level of resignation. So I think that communication of risks is one thing. Possibly that's not different to genetic tests, but I think that there's the possibility for, given that epigenetics is possibly still more in the imagination of the general public than it is fully understood, I think that there probably is the possibility, or a high possibility, of misunderstanding. I guess one of the other things that again came up in the symposium is the question of the epigenetics of trauma, and the question of how or whether trauma is passed down through generations. And I guess this also goes back to what Evie was saying about other types of interventions. So if we think about the epigenetics of trauma, what does that actually tell us about how we respond to trauma, how we conceptualize trauma, and is the contribution of epigenetics in that space useful, I guess, or how is it useful? And how can it be used in a way that's not overly, I guess, medicalizing, if that's the term that you want to use, the experience of trauma. And what does it, and possibly how does it connect to the idea of stigmatization, and what individuals feel like they can be empowered to do about traumatic experiences, whether that's individual or generational or societal. I don't know if that was a very clear response.
Yeah, I think the empowerment is an interesting idea because of the plasticity of epigenetic marks. That's the assumed plasticity of epigenetic marks. We never quite know exactly how fixed they are, because epigenetics is also influenced by genetics, but potentially it is about the idea of individuals being able to react to their epigenetic tests and being able to change their epigenetic state. And that may be something that's interested to consumers, for example.
Yeah,
Thank
agreed. And
sorry, Evie, can I just jump in, just because we've only got 2 minutes scheduled left for questions. If you have any other points, would you mind just popping them into the chat? But actually, I was going to ask the other question to you, because I think it pertains particularly to your presentation. Maurizio Coppo asked, and I think it's really a factual question, but whether sport governing bodies are starting to talk about biohacking in the same vein that they talk about anti-doping, I guess. I'm sure it's on the agenda of bodies like WADA, etc. But if you happen to have any information, as opposed to my guess, that would be great to hear.
Well, this is a great example of your guess is as good as mine. So I have a deep and abiding hatred of all competitive sports. It's practically an allergy. So I make it my business to not know what the sporting governing bodies are doing. But I am sure that it is something that's being discussed. I doubt it's being discussed with the term biohacking or bioengineering. I'm sure they just consider it another form of doping. So, I mean, we know, unfortunately, that can be misused as well. So the idea that, certain naturally occurring sort of hormone levels, individuals who are intersex, for example, are being demonized in sporting governing bodies at the moment, etc. And of course, things happening to the community of transgender individuals as well. So I'm sure there will be capacity for even more discrimination against people if they start discussing sort of genetic therapy as a potential doping issue. Then it will become a case of which genetic therapies are approved and which are considered biohacking or enhancement or doping. So I'm sure the discussions are going on. I'm sure they're not using exactly the same terms as we're using here, but yeah, and I suspect it will unfortunately lead to more discriminatory practices against certain athletes.
Okay, thank you. Thank you for such a great wide-ranging discussion, and to both of you for giving your time so generously to this. I'm now going to stop the recording and say goodbye, and thank you to anyone who has viewed this online.